what is all this? Again, kind of gibberish. What does this mean? Well, 0 is very clear. 0 is 0. I am asked to find g prime of negative 2. What does g prime of negative 2 mean? G prime of negative 2 is the instantaneous rate of change of g at negative 2. Okay, what does that mean? Okay, so this is negative 2. I will draw a tangent at negative 2, a tangent line at negative 2, and I will try to create a triangle. In order to find the slope of a line, I need rise over run between any 2 points. So I pick this point and this point. I'm going to say roughly this is all an estimate. There is nothing I can do determine this exactly. But I'm going to say that this is kind of looks like a 3, and this kind of looks like a 1. So maybe you can say, no, it appears to me 2 and 1. That's fine too. I agree. Difficult to say. I would say 3 over 1. Maybe I would agree with 2 over 1. So I'm going to say approximately 3. So I have a number for this. Then I'm asked to find the instantaneous rate of change of this function at 0. Okay, fine. I'm going to draw a tangent. I'm going to create a triangle. To me, it looks like a 1 over 1, but it's negative. So I'm going to say g prime of 0 approximately negative 1. Then they want us to find the g prime of 2. Okay, fine. I will draw a tangent. Definitely this is less steep than this. If I consider this to be 3 over 1, this looks to me like 1 over 1. Definitely less steep than this. If I want to walk and I'm lazy, I want to walk on this. I don't want to walk on this. More difficult. So this is steeper. So I will say that g prime of 2 is approximately 1. And the last one at 4, I'm going to draw a tangent. This is the instantaneous rate of change at 4. Definitely this is the smaller of this tangent. This is definitely negative, so it's definitely the smaller. But this is steeper, less steep, less steep. Again, if I'm lazy, I prefer this one. So here I'm going to say something like 2 over 1, but of course 1 over 2. So g prime of 4 is approximately 1/2. Are these numbers carved in stone? No, this was my estimate. And now I want to arrange them in ascending order. Fine. I'm going to put this one first. So this is number 1 because it's negative. I'm going to put 0 first. That will be number 2. Then I'm going to consider 1/2. So this will be number 3. Then I'm going to consider this as number 4 because it's 1. And then I'm going to consider this as the steepest, so it's number 4. So in an ascending order, 1, 2, 3, 4, 5. So now if this is, let's say, a profit function, and we have our boss, and she comes to us and says, hey, from this time period, January till December, in this year, when would you say that our profit had the biggest instantaneous rate of change? What would you say at this point from the ones we looked at? When would you say, boss, look, at this point, your rate of change of profit is negative. That's bad. And then you will say, boss, okay, now here it was 0 because the slope is 0 of this point at 1. But from this point on, you have your profit, your rate of change of profit started increasing, but now again is kind of getting flat. So this was your best. This was the top for this area. This was, it started to become negative. then you had 0, and then you had some improvement, but now you're kind of flat again. So this is the analysis that we would give to the boss based on this graph. If this is profit or cost or whatever else, volume or labor, whatever. So this was the best increase, the highest increase. The highest increase is basically here, and then it flattens, and then it reaches a maximum because the slope is 0. Then it kind of starts decreasing, decreasing, decreasing. The slope is 0, so this is a minimum now as we see it. And then it starts recovering, but not that much. This is the analysis. These are some of the things that the first derivative is teaching us about the function. Not everything. We have way more to learn from it. And I'm looking at the time. I know as a token of respect to you, I have 3 minutes. I wanted to show you at least one example of how to determine f prime, but unfortunately, I don't think I have time in 3 minutes. But I will give you the definition again. So let's write the definition. This has to be memorized forever. The limit as h approaches 0 from f of x plus h minus f of x divided by h. You know now how this was composed from 2 super important concepts: the difference quotient, which is the slope of the secant line, and the concept of the limit, the tendency of the slope of the secant line. And this gives the instantaneous rate of change, or velocity, or the slope of the tangent line at any point where the original function is continuous, does not have a cusp, a corner, or a vertical tangent. So one last thing: continuity, differentiability. Question: this implies this, this implies this, or both? Which of these is correct?
Continuity implies differentiability.
Okay. The answer is never. Here's why. This function is continuous, but it's not differentiable. This function is continuous, but it's not differentiable. This function is continuous, but not differentiable. So this is not.
So then just differentiability.
Just exactly is the correct answer. If a function is continuous, there is no guarantee it's differentiable, unless it doesn't have a cusp, a corner, or a vertical tangent. Yes, then yes. But if it's differentiable, it must be continuous, otherwise it would not be differentiable. So this is the only one that is true. Awesome.